Hi guys, Mrs. Sugi here. This video is going to cover section 8.1, and this is the set of notes that's posted in Canvas for you, although it looks more like a worksheet than our typical notes. So it is a little bit of an activity that we're going to go through, and I just decided these were pretty good for section 8.1. So you may want to add a title at the top so you don't forget at the end of the chapter what your 8.1 notes look like. All right, so we are going to start filling out this chart, and by the end we are going to arrive at some patterns that we can make some formulas out of. And we are just talking about polygons to start with in this chapter. And naming the polygon, that should be easy for most of these. You probably know a lot of them already, but we have a triangle, 3 sides. Number of triangles formed. Well, there's only one triangle here, so we only have one triangle. Okay. The sum of the measures of the interior angles. That means if you add up the 3 interior angles, that one plus that one plus that one. Okay. What do they all add up to? We learned that first semester. For triangles, it's always 180 degrees. Okay, and then the measure of each interior angle of a regular polygon. All right, so we didn't talk about regular. I'm not sure that we talked about regular, but regular just means that all of the sides and all of the angles are completely equal. And really what we're interested in for this is angles. So if all of these angles were exactly the same size, how big would each angle be, right? So we know that because there's 180 degrees total for all 3 of them together, we would just take that 180 divided by the number of angles that we have, and that would give us 60 degrees. So once you fill out a few rows of this chart, you'll get the idea. I encourage you, I won't do the whole thing on the camera, but go across the rows because the patterns jump out a little better, I think, of what we're trying to get to by the end instead of going down the columns. I'll go through maybe the pentagon with you guys. Okay, next shape, it looks like a square. I guess if it's any 4-sided figure will follow most of these rules, though. So we're going to call it just a quadrilateral. Quadrilateral. 4 sides. Now, number of triangles formed can get a little tricky. So the way that we're going to create triangles is pick only one vertex. It doesn't matter which one. Pick a corner. Okay, and then draw as many diagonals as you can, as in lines that can go to other vertices. In this case, I can only draw one, because I can't draw a line over to that corner without it just being the edge of the figure, and etc. Okay, so we just formed 2 triangles. Each one of these triangles contains 180 degrees, right? Between those 3 angles, that's 180, and these 3 angles, that's 180. So theoretically, if I wanted to add up all the angles for a quadrilateral, I would take my 2 triangles that I formed, right, and times by 180, and I would get 360 degrees. And so that is the sum of the measures of the interior angles. Okay, and now that I messed up my picture over here, the next column says find the measure of each interior angle in a regular polygon. All right, so regular would mean if I would take this little square, I'm going to go ahead and take any quadrilateral and then turn it into a perfect square, right? This would be regular. So it's kind of hard to mark this, but regular would be all the sides are equal, and really what we care about for this last column here is all of the angles. All right, so if we know that all of these angles are adding up to 360 degrees, and there's 4 of them, I would take 360 divided by 4, and that would tell me that each one of these corners, each one of these angles is exactly 90 degrees. Okay. Next one down is the pentagon, 5 sides. Okay, how many triangles can we form? This is the column that people goof up mostly. So pick any vertex. It doesn't matter which one. Okay, and only from this vertex are we going to create triangles. So we're going to draw a line to there and a line to there. Those are called diagonals. Okay, so I just created 3 triangles. Okay, now each one of these triangles has 180 degrees. So if I wanted to find out the sum of the measure of the interior angles, I would just do 3 times 180. 540. I'm just going to draw a little picture here for that so you get the idea. Because now that I've messed up my picture by drawing outlines on it, sometimes it's hard to get the idea. But I'm going to draw a pentagon. I'm going to make it look like a house because I know that's a pentagon. And it doesn't have to be irregular for this. But what that sum of the interior angles is saying is that if I take all of these angles, 1, 2, 3, 4, 5, for a pentagon, they will always add up to 540 degrees. 540 degrees. Right? Each shape has their own signature interior angle sum. Triangles is 180. Quadrilaterals is 360. Pentagons are 540. Now, if it's regular, right? Regular means that all the sides and all the angles are equal. I'll do my best at regular here. All right, so all of these angles are equal, which means we should be able to figure out what one of them is, right? So we're just going to take our interior angle sum, which we just said was 540, and we're just going to divide that by the 5 angles so that we get an even number of degrees for each angle. And that is 108 degrees, right? So we're taking this number and we are doing 540 divided by 5, 108 degrees. So that's what it means to find the measure of each interior angle in a regular polygon. All right, I'll do pause the video and try row 6 or the hexagon and then check in with me. And then we'll go from there. Okay, a hexagon, 6 sides. You can make 4 triangles provided that you do it the way that you got to do it for this activity, and that is pick only one vertex and draw as many diagonals as you can. So that creates 1, 2, 3, 4 triangles. Right. Each one of those 4 triangles contributes 180 degrees. So we know that if you added all the angles of a hexagon, right, I try to draw a little picture right here. So this 720, right, that just means we're taking all of the interior angles, adding them up. Hexagons have their own special signature number, and it's 720. Okay, and then if I wanted to know how big just one of those angles is, it would have to be a regular hexagon. But I would take that 720 and divide it by the number of angles that there are, which is the same as the number of sides. And then you get 120 degrees. All right, so go ahead and work your way down the chart. And just observe what happens as you go across the rows, because we're going to try to come up with a couple formulas when we get to the n-gon. So this is not 11, okay? This is just the generic way that we call polygons, where they have a lot of sides that we don't have a special name for them. So if it was like if it had 13 sides, we would call it 13-gon. All right, and so we're going to try to generate some formulas down here. I'm going to go ahead and put myself on hold and finish the chart, and you guys finish the chart as well. Okay, so take a minute, maybe pause the video if you need to, and fill in the boxes you were unable to fill in. The heptagon is a little unusual because it does have, first of all, a lot of people don't know the name for the 7-sided figure, but it does. It's one of the ones on this. It's the only one on this chart that has a decimal 1 angle measure, but that's not completely unusual. That will happen, with a lot of the figures. All right, so let's go ahead and do the n-gon. N-gon. Okay, so the name of the polygon for an n-gon is still an n-gon. And an n-gon has n sides. So if it was a 17-sided figure, it would be called a 17-gon, and it would have 17 sides. How many triangles could be formed? So hopefully as you went across your rows when you filled out the chart, you noticed that there were always 2 less triangles than number of sides. And that is true all the way down those 2 columns. So we would describe that as n minus 2. That's how many triangles are formed. All right, to get the sum of the interior angles, as in take that n-gon and add up all the angles inside, what we always did was we took the number of triangles, right, and we times that by 180. And I know this kind of gets cut up on my chart a bit, but that is true all the way up the column. So if you didn't put this step in your boxes, you may want to put that in so you can see it. But what we did was we took the number of triangles formed and we times that by 180. All right, and that is a formula. All right, and that is called the SI formula, as in sum of the interior angles formula. I'm going to rewrite it down here. SI equals n minus 2 times 180. And you'll want to highlight, box, do something so that formula jumps out at you, because it's at the very bottom corner of your paper. And when you look back on this, you may not realize that that's the important part. That's the culminating point of this entire front sheet of the paper, this column, and we're going to have another formula here. All right, so I am going to highlight this formula. And bubble cloud it. Sum of the interior angles. And the other thing you may want to do is at the top of this column, I don't know, maybe should have done that from the beginning. We'll call that the SI column. Sum of the interior angles. Okay, going down again, now we need to figure out what's happening in the last box. This is our last formula. So this is when we're finding one angle. So this is called the one angle formula, one angle. And unfortunately, it doesn't have a nice little variable that we can call it. So I always just call it the one angle formula. And what we did in this box, all the way down the column, is we took that SI number, right? The SI number, that big SI number, and divided it by however many angles we had. And the number of angles that we had always matched the number of sides that we have, right? Here's our SI number divided by number of sides. And the number of sides, that's just the same as the number of angles that we have. So what we are doing here is we're taking the SI number, n minus 2 times 180, and we're dividing it by the number of angles on there, which is the same thing as the number of sides on that. All right. So one angle equals, and there's our one angle formula. And just, you know, the one key about this formula is it works only if you have a regular polygon. And that tells you that all of the sides are the same length and all the angles are the same sizes. So really it's the angle information that we care about. Okay, and yep, those are the two formulas that we're going to be working on the back. There's a lot of different things we can do with these. Okay, so we'll just practice working these formulas a little bit. Number one is, what is the sum of the interior angles of a 23-gon? All right, so you have to get good at reading those phrases, you know. Sum of the interior angles is the SI number. And we can't really draw a 23-gon, right? Good Lord, 23 sides. But what it's asking is if you were going to, right, add all the angles up in a 23-gon, what do they all add up to? Every shape has their signature number. And we would expect to have a pretty big number because 23 angles is a lot of angles. All right, so here's our formula. We're using the SI formula. 23 minus 2. And hopefully you can kind of see what's happening. If it's got 23 sides and you did the triangle thing with it, you would have 21 sides, right? Or 21 triangles, excuse me, times 180. And that is 3,780 degrees. All right, and that one is done. All right, what is the measure of one interior angle of, oh, and there's a word missing. Should be regular, because technically if it's not regular, we can't figure out how big one angle would be. But if it is regular, you know, that means all of the angles would be the exact same size. All right, so again, kind of impossible to draw an 18-gon, but say there's 18 sides, right? And we want to know just how big one of those angles is, right? And all of the angles are the same size because it has to be regular. So we are going to do the old one angle formula. And that means we get the big SI number first. And then we're going to take that big SI number and divide it by however many angles there are in the polygon, which is always the same as the number of sides. So for us, that'll be 18. So 18 minus 2 times 180 over 2. No, over 18. 16 times 180 over 18. All right, 16 times 180 is 2880 degrees. That's the big SI number, and we're going to divide that by 18. And we get 160 degrees. All right. Okay, this next one's a little bit more complicated. It says, given that the interior angle sum, that's the SI number, SI, of a polygon is 2880, classify the polygon. That means that we're supposed to say how many sides it has. And boy, that 2880, I feel like we just did that on number 2 kind of, but this is an example where we're working backwards, right? So we know the SI number. We know what all of these angles add up to, right? If you could add them all up. So because every polygon has their signature number, that means that angle sum belongs to a special polygon, and we're trying to figure out which one it is. Man, we just had that number on example 2, so I think I already know what the answer is. But let's go ahead and do it. Well, we had it as part of number 2, didn't we? Okay, so they're giving us the SI number. So we're going to go ahead and use our SI formula. And this time, we know what SI is, right? 2880. And so we'll just replace SI with 2880, and then we're just going to solve what we have. I will say, I mean, there's a couple different ways to approach this, but I think it's kind of nice, keeps our numbers smaller in many ways, to divide away the 180 first. And that's kind of like taking that 2880 divided by 180 and dividing all of the big angle sum into 180 degree increments, which technically that's telling us how many triangles we have. And then all we do is add 2 back onto it, because we always know that there's 2 less triangles than number of sides, which means this had 18 sides. I guess that would classify it as an 18-gon. All right, and example 4. Now we know that one interior angle of a regular polygon is 170 degrees. Classify the polygon. That means figure out how many sides it has so we can name it. All right, so we know that if it's regular, right, one interior angle is 170 degrees. So we're going to use our one angle formula. All right, this one's going to be have a little bit more involved algebra work, but we know the one angle is 170, so we're going to put 170 in for that one angle, and then we are going to solve for the n. Okay, well, this is basically, I mean, it looks a little complicated with an n in the numerator and an n in the denominator, but if you turn the 170 into a 1, essentially we can just, not the 170 into a 1, turn the 170 into 170 over 1. We'll just make a proportion, and then we can cross multiply. That's one way to get around the complication here. So we have 170n equals n minus 2 times 180. It'll just stay the same since you're just multiplying it by n. All right, and now, I mean, it is different than the one we just worked on the left, example 3, so I believe we are going to have to do this step right here. 170n equals 180n minus 360. And then we'll just roll on about solving. So 36 gone if you wanted to give it its official name, but the end kind of is far enough if you just take it to there, 36 sides. Okay, that's a lot of sides and pretty big angles. You can see, I mean, 170 degrees is just 10 shy of 180. Once you get to 180 degrees, you have a straight line. So it is always interesting to think about, I mean, at what point will something with so many sides begin to just look like a circle or like a big straight line if it gets big enough? Okay, example 5. I guess the one thing about this is this picture is really hard to read. So this is supposed to be x. This is, I believe, x minus 20, and then this is x plus 20. Okay, so we are trying to solve for x now. We have just a generic polygon here. Let's count the sides. I always have a hard time counting sides for some reason. I go too far or not far enough. So that's my number 1 side with a check mark. I'm going to count it as 1, 2, 3, 4, 5, 6, 7. It's got 7 sides. All right, and 7 sides, again, polygons have their own signature interior angle number, right? We know that all of these angles have to add up to a special number. I mean, 7 is something we could just literally look up on the chart we did earlier, right? If it's got 7 sides, we know its SI number is 900. So we know that all of these angles have to add up to that 900 degrees. So I'm just going to make a big giant equation. X plus 150 plus x minus 20 plus 140 plus 120 plus x plus 20. I'm running out of space, plus 130. Those all have to equal 900 degrees. And then it's just a big giant lesson in or endeavor to combine all of your like terms together and turn it into an equation that's more manageable. Okay, so I had to just do it off camera so I didn't make the video even longer, but it's all of those numbers add up to 540, and the 3x's add up to 3x. Okay, then we'll just solve away. 3x equals 360. 120. Okay. All right, and that is it. Good luck with your polygons.